Welcome. This is the second part of constant rate of change. So let's look at our number routine. A tank holds 5,000 gallons of water. After 6 hours, it now holds 3,800 gallons of water. The water engineer says the rate of change of gallons per hour is 200 gallons per hour. The mayor says the rate of change of gallons per hour is negative 200 gallons per hour. Who is right? Well, let's see. Um, I'm going to need more space in this, so much better. So we're going to see who is right here. Well, first of all, it held 5,000 gallon water. Now it holds 3,800. So that is a leak of how many gallons of water? 1,200 gallons of water. So that's a leak of 1,200 gallons of water in 6 hours. I would like to know what is the rate of change. How is it changing every hour? Well, if I divide 1,200 by 6, it's 200 gallons of water per hour. So is it changing 200 or is it negative 200? I believe it's negative 200 because it is leaking, so it's a negative rate of change. So negative 200 gallons per hour. You got written, it is leaking 200 gallons per water, or using the number negative 200 gallons per hour. So, today you're going to be using some tiles. So you're going to be finding the figure number and number of squares. In figure number 1, there are 2 squares. In figure number 2, there are 4 squares. In figure number 3, there are 6 squares. In figure number 4, there are 8 squares. Can you draw figure number 5? If I can continue the pattern, it's 10. So it is changing by 2. So write an equation, show the relationship between the figure number x and the thing. First of all, is it additive or is it multiplicative? It is multiplicative. It is times 2. What are you multiplying 2 by? By x. So it's y equals 2x. Does the equation represent a constant rate of change? Yes, it does. Because you're adding 2 squares to every figure number. You can see it right here. It is increasing 2 squares, 2 squares, 2 squares per figure number. So it does show a constant rate of change. So we can see it through the picture and we can see it through the table. And if we had made a graph, you'll be able to see it that is changing, going up to every figure number. In this one, in figure number 1, there are 2.5 squares. In figure number 2, it seems like they're adding 2.5 to it from the original shape. So there are 5 squares. So this had 5 and then they added 2.5, so it's 7.5. And here we had 7.5 and then they added 2.5, so it's 10. So in figure number 5, how would you draw figure number 5 if you had to? I would add one white square, another white square, and a triangle here. So it'll be 12.5. So write an equation to show the relationship between a figure number x and the number of square tiles y. So what is the relation? Is it additive or multiplicative? What's the relationship between 1 to 2.5, 2 to 5, 4 to 10? I believe the relationship is multiplicative by 2.5. So it's 2y equal 2.5x. And does this show a constant rate of change? Yes, it does. Because if you look at the picture, every time we have another change in the figure number, it changes by 2.5 squares. And we can see it through here. We can see it through the picture that there's a constant rate of change. In our last activity, what you're going to be doing is you're going to be doing a real-world connection here. The Mamie Junior High Student Council is planning a trip to a water park. There are 2 water parks in the Houston area, Typhoon, Texas, and Wet 'n Wild, Schlitterbahn. No, I'm sorry, it's just called Wet 'n Wild. Assume that both parks are equal in popularity. Typhoon Texas charges $15 per student, flat rate. Go in, you pay $15. While Wet n Wild charges $10 per student, but they charge a one-time $20 rental fee for the pavilion. Which park would be the most economical, better price? You're going to create a convincing presentation to the McMean Junior High Student Council sponsor, pointing out which water park is a better deal and why. Support your presentation with graphs, tables, and persuasive paragraph. Which water park charges a steady or constant rate of change for cost per student? You may use a calculator. So you're going to create a table. And then for Typhoon Texas, you're going to write an equation to show the relationship between X and Y. And then you are going to graph it. And through this graph or through the table, you're going to realize which water park is cheaper at a certain point. Then it should be tied. And then another water park will be cheaper at another point. And then through that, you're going to tell me which one is a better deal. And then you're going to tell me which water park charges a constant rate of change for same price per student. There is one water park that charges the same steady rate, no matter how many students you bring. And then there's a rubric. All right, that is our lesson.